This video tutorial will help you understand mineral physical properties. To identify minerals, us being both geologists and you, we're going to use diagnostic physical properties that we can observe or test on hand samples, so hand-sized samples of minerals. The principal properties are luster, which is how the mineral surface reflects light; hardness, which is the resistance of a mineral to scratching, and we test this relative to known hardness of different materials; mineral shape. It can be two things: cleavage, which will be a distinct pattern to broken mineral crystal, or habit or form, the shape of an unbroken crystal. Mineral color, mineral streak color. This is the color of a powdered mineral. Tends to be more diagnostic. The two major kinds of luster, or how light reflects off a mineral surface, are metallic and non-metallic. All of the examples here are minerals with metallic luster, and so there's three criteria that have to be true for something to be considered a metallic luster. First, it needs to be a metal color, so think chrome, aluminum, gold, other jewelry types of colors. It has to be shiny. It has to reflect light pretty well in a shiny manner. Very scientific, not really, but I think we all understand what that is. It's not a flat or a dull surface. And the third thing is it must be opaque. That means light is not going through the surface. It's not transparent or translucent. In contrast to metallic luster, all the examples here are non-metallic luster, and this is kind of a wastebasket category. That means basically anything that's not metallic is going to be considered non-metallic. All the other kinds of surface appearances, it can be dull or shiny or transparent or pearly. These are some different examples of names for luster. We're not going to worry about all those specific names. We need to know non-metallic and metallic. So I have a couple of questions for you as we go through. Can a mineral have no luster? Take a minute and think about what this means and pause while you're thinking. Come back and we'll go over the answer. The best answer is no, all minerals have luster. And here's why. Your eyes require light reflecting off objects in order for you to perceive them. So light reflects off everything that is technically visible. If you couldn't see it, that might mean that no light is reflecting off. It would be an invisible object. So when we're talking about luster, we're talking about the quality or the properties of light reflecting off the mineral surface, not whether it does or not. The next property we'll discuss is mineral hardness. And mineral hardness measures a mineral's relative resistance to scratching. This is a little bit different than mineral strength, or whether it's brittle or fragile or anything like that. Technically, hardness is just the mineral's resistance to scratching. So knowing this definition, which item will leave a scratch? A harder material or a softer material? Take a minute and think, and then I'll give you the answer. Okay, you're going to be doing a lot of this, or I should say for this class, you're going to be watching me do this a lot. The item that is harder will leave a scratch on the softer mineral, and that's how we're going to figure out, relatively speaking, how hard or soft a mineral is. There's two aspects of mineral shape we're going to be working with, and the first is known as cleavage. Cleavage is referring to the fact that some minerals show a distinctive pattern of flat surfaces when they're broken, say with a hammer. So we've got several options for this. Geologists characterize cleavage of a mineral by its presence, that is, whether a mineral possesses cleavage or a sample possesses cleavage or not. If it doesn't seem to have cleavage, usually we say it has fracture. That is, it has irregular broken surfaces instead of these nice, relatively neat flat surfaces or stair-step kind of pattern we'll see when it has cleavage. So besides presence of cleavage, Some minerals have a distinctive pattern of cleavage in the number of planes that occur or flat surfaces that aren't repeating throughout, and by the angle where planes intersect. So we've got some examples here. Flat kind of minerals that break off in sheets tend to have one plane of cleavage. Other minerals can have two cleavage planes, and they can be at right angles or 90 degrees to each other. We've got another example where there's three cleavage planes at right angles to each other. And then we've got another example where there's no cleavage planes. We'll say that this mineral only has fracture. So to reiterate, how minerals break can be diagnostic. That is, it's a characteristic that can help us identify the type of mineral we're looking at. The number and directions of cleavage are characteristic for types of minerals. Minerals can have 1, 2, 3, or 4 directions or planes of cleavage. And that mineral we were looking at before that seems like it breaks off in sheets, that's a member of the mica family of minerals. And they all have one direction or one plane of cleavage breaking into thin parallel sheets. There's another video online that I put together that illustrates the different types of things that happen when minerals are broken or smashed. And so I invite you to take a look at that as well. In the meantime, I've got a couple of examples for you to try to figure out if we can identify what type of cleavage or if cleavage is present at all. Not all minerals exhibit cleavage. If there's no planes of weakness inside the mineral, which sets it up for having cleavage, then we say it breaks irregularly or has fracture. So this example, we've got two mineral samples or two types of minerals that look very similar in their right-hand version, the crystal or the unbroken crystal. They're both clear, transparent, whitish, grow in these six-sided crystals as it turns out. But if you break a larger crystal with a hammer, as we see on the left-hand side of each image, you notice some differences. Sample A breaks irregularly. Irregularly, we would say it only has fracture, no cleavage. Sample B, there's still a little bit of irregularity, but do you notice how it breaks into almost a cube shape? That means that it probably has multiple planes of cleavage that are influencing where and how it's going to look when it breaks. I've got a couple of examples for you now of minerals being broken, filmed in slow motion. I didn't do this, but another geologist has made these available. So I think we've got 3 examples. Keep in mind as you're watching each example whether you think this is cleavage or fracture being exhibited and how confident you are about either one. So let's watch the first one. What do you think? Did this previous video show fracture or cleavage? Surprise, I'm not going to tell you the answer right away. We're going to watch a couple more videos and we'll see if you change your mind. So watch this one again. This one, the mineral sample is pretty soft and you can actually just make it break by squeezing it in a pair of vice grips or pliers. Again, did the last video show fracture or cleavage? What makes you think one or the other? And I've got one more video. Take a look and see. Again, this one's going to be smashing with a hammer, and we'll see what you think, cleavage or fracture. Okay, here's your chance to really try to come up with an answer. Cleavage or fracture for that last video. Pause it for a couple of minutes, not minutes, seconds while you think about it. Okay, so I'm going to reveal the answers. Hopefully you now, after seeing all three of these, would agree that the first video shows fracture, irregular surfaces, and pieces that are created as the mineral's broken. And the second two actually show cleavage. So different patterns in the cleavage. Sometimes you can see the light reflecting right back at you all at once along one of those broken surfaces. That sometimes is a really good characteristic for identifying cleavage. I call it the flash. You'll find out that color or mineral color can be diagnostic for some minerals, but most minerals exhibit more than one color. So the best advice I can give you is use it with caution along with other properties. Streak color, that is the color of the powdered mineral when you rub it back and forth across a hard ceramic or porcelain streak plate. It's going to be more useful than the mineral color itself. It's especially useful for metallic minerals like hematite. It can be a really different color of the streak than from the appearance of the mineral. Okay, so this is the last slide or last thing for this video. You'll notice that Lab 3 actually will lead you through a lot of these properties and how to observe for them. So that is the point of Lab 3. This is a very short introduction to get you used to this. And then please also watch the cleavage or the breaking minerals video. That will help you a lot with the property of cleavage. Thanks and see you later.